Really nice to be here talking about generative AI. So my talk here is talking about that working software is still really important. So let's look back like a little bit, because the concept of working software is actually one of our core principles from the 12 core like agile principles. So we're talking about the working software is the primary measure of the progress. So that is actually something new came into software delivery like about 20 years ago. So about 20 years ago, people don't really think the working software is the primary measure. People think about the progress, because like you have like different phrase for your procedure. People think about, oh, the progress of the procedure can be an indicator or like measure of the progress. But this agile community came into the software like delivery like community is actually talking about no, it's actually not true. So working software is actually can be the only primarily like measure for the like software like progress. So let's think about why. Because why that is actually really important. So the underneath is actually a little bit deeper like than itself. So we have to rethink about what is the software development is really about. So there's a really interesting perspective from here too. Because I always compare software delivery as someone writing a book rather than like build a building. Because when you're writing a book, there is a twofold for the exactly same thing. Because for the reader, the software itself is the product. Because if you're reading a book, you think, oh, the book itself, for sure, that's a product. But as an author, the book itself is actually not the product. Because if you're writing a fiction, the character, the storyline is actually your product. So if you're writing a non-fiction book, then the point, the perspective, the structure is actually your product. Then there's two things we've been talking about here. Something the customer can consume, but something from an author perspective, what we really care about. Then the same things happens for software. For software itself is more a medium rather than the product itself. The product itself is actually the knowledge embedded within the software. Or in another way, so we can say the software is a codified knowledge. It's a codified knowledge. So in that sense, we can only see this software like delivery as a knowledge management like process. So the whole software delivery is not like building something, but it's more like how we're actually managing the knowledge. We can only see the software managing the software delivery procedure as a knowledge acquisition procedure. So just as like Rachel mentioned, coding is only a small part of that. Or we can in another way say, if you don't put the knowledge in the brain of your developer, you will never have that piece of knowledge reflect in your code. I will say that again. If you don't put the knowledge in the brain of your developer, you will never have that piece of knowledge in the code. Because nobody can write in the code they don't know about, right? Because so any bug in your software is actually an indicator for a leaking of knowledge in your whole delivery procedure. That may be something is being missing during the knowledge transfer or is being misunderstood. Like consider that anytime you found a bug, the developer doesn't understand so the architecture they were being working with, or the business analyst doesn't really understand what this customer or the client is really want. Then, or when you're putting this thing online, then the customer say, hey, that is something we don't want. So anything in the defect of your software is actually an indicator for the knowledge transfer. And knowledge transfer is actually not that simple or that easy. Because here is something like really interesting, because Shang-Chi actually challenged me to talk this story like in English, like I will try. Because in modern knowledge management framework, there's three types of knowledge inside of two. Because people always say there's two types of knowledge. There's implicit knowledge, there's explicit knowledge. No, there's a third type. The third type is actually called the tacit knowledge. So what is a tacit knowledge? So the tacit knowledge means it cannot be expressed, or the information using to describe this knowledge is actually not useful. So there is a story. It's really interesting and can be perfectly like describe the testing knowledge. It's actually 2,000 years ago from a book like in China called like 庄子. So like in that book, they're talking about a like story. So say there's a really old man like on the street to making a car wheel. So a man came to this like really old man, say, why do you making this car wheel by yourself? You can have a student or you can have your own son to building that for you. So the old man say, okay, I will tell you the trick to run a business as a car wheel maker. So the secret for make a car wheel is you can't make it too slow. Because you make it too slow, you can have a perfect round, high quality product, but the cost will be so high. You can't really run a business with that cost. But also you can't make it too fast, because if you make it like really fast, you can make many wheels per day, but the quality is actually not that good. So the key here is actually not too fast and neither too slow. So but that kind of technique, I can tell you the key is not too fast, not too slow. But to actually master that, you have to build in your own. Because that is actually, as the old man said, it's actually like between my hand and my brain. So that is actually the very first time the Chinese motto 得心应手 ever like appeared in our culture. It means you have to understand that you have to be reflect in your hands. So that is actually means there is a set of knowledge. It's actually not easy to transfer. That is actually you have to learn in the context. You have to have a mentor to provide in-time feedback for you. So that is why today in modern knowledge management the framework, people always emphasize there's only one way that it can be easily to transfer the testing knowledge. It's actually called socialization. So which means you have to making people talking face to face, working in pair, provide fast enough feedback for them. So if you consider the whole agile methodology, you will see we actually see in software delivery most of the knowledge being transferred is actually testing knowledge. Why is that? Because starting from this business vision, you divide that into each different iteration. But you will have a iteration kickoff meeting and a showcase as a feedback loop to make sure the stakeholder and development team understand each other well. Because the business vision is a testing knowledge. Nobody know for sure what kind of functionality can fulfill a business vision. Then from the story point of view, so when you have a story being kicked off, the business analyst and the developer is talking with the story kickoff and with the desk check. So that is also a socialization to close this feedback loop. Then everyone going to say, okay, we understand that this user story, we understand this value can be mapped into this particular functionality. And then we will further break it down. It came into one of these acceptance criteria. Then you have the pair programming. So one developer to break it down, or the two pair to actually break it down into a task list based on this architecture and your test strategy. So that is actually means architecture and what is the best way to test software under certain architecture is a testing knowledge. It's not easy to be transferred. So you will see why agile methodology actually works. Is the very first methodology in software delivery. We actually consider software as a knowledge management procedure. So every practice in agile engineering, it has a engineering side of it, but it's also thinking from knowledge management perspective. So you can always think about those engineering practice as a way we manage knowledge. So that is actually one of the really important thing. So if people think about the knowledge transfer is really important. It's the fundamental difficulty and complexity for software delivery. But why we still emphasize or fixating on working software? So that's actually really interesting because we specifically call out working software is actually to close the feedback loop. Because you can say, I have a perfect software delivery process. Everything goes really smoothly. So our knowledge is actually transferred perfectly, but we can't produce the working software. then it actually doesn't mean anything. Because it's more like I have a dragon like in my garage, but you can't sense it. So we can just like assume you don't have a dragon. So we need something to close the feedback loop. So working software is around that time the only thing we can have to close the knowledge transfer loop. So we'll finally know whether or not the knowledge is being transferred into the developer's brain. So that is, they can actually writing the code. So then the question is actually like become, does AI or large language model change anything? So before we came into how large language model can change that, we'll provide a perspective. How should we think about the large language model? So here is someone say from Microsoft. They say, okay, here is a Xiao Law. Xiao is the deputy CEO for Microsoft. He actually talking about a lot of things. Some of them is actually not really valuable, but I think one thing is really important. He actually talking about the code is actually for the syntax and the procedure, but the model is actually for the semantic and the intention. That's actually interesting, because in software, there's a fundamental difference between what system is and what system does. So what system is, we're talking about the system's intention, purpose, value, and impact. And what system does, we're talking about the functionality and how we implement those functionality. So the separation between what system is and what system does is the fundamental difficulty in software development. I will give you guys one really simple like example, because the really simple like example here will be, let's define what is square root. Square root, we can define that really easy. So if x times x equals y, which means x is the square root of y. That is definition. What is the square root? But based on that, can we develop a program to calculate the square root of 2? We can't do that. Right? Because from the definition, we know the purpose, we know the intention, but we don't know the algorithm to actually calculate that. But we'll see the actually program to calculate square root 2 is an iterative algorithm to do the whole thing until you find a fixing point. But by looking the code, you will never reverse engineer the intention for this piece of code, because an iterative algorithm can do so many things, because we can't really telling you what that is exactly for. So then that is actually the fundamental difference. But then here we actually say the model is actually for the intention and the semantic. The code itself is actually for the syntax. So it's actually say we should think about the model them first. So then the real question is going to be how large language model actually change the knowledge accretion. So from there, I was still talking about something first. First, we need to think about the large language model as the really cheap in-place transfer learning. In-place transfer learning. Because like before, the transfer learning is you have a machine is training for a particular job and task. Then you need to using certain data to retrain the later layer. Because broadly speaking, because in the deep neural network, you're gonna have the data processing layer, you're going to have the feature layer, you're going to have the decision layer. So the basic idea is we can retrain the decision layer to transfer a particular trained AI from somewhere to somewhere else. So even today, for large language model, people are still taking that approach. You guys hear the latest news for ChatGPT 3.5 is they released the fine tune for the fundamental model. I think it's like 3 days ago. So that is the traditional transfer learning perspective. But think about ChatGPT. ChatGPT, what is ChatGPT actually training for? So ChatGPT is actually training for reading comprehension. Because the only capability ChatGPT is good at is actually reading comprehension. So which actually means when you give to the ChatGPT your prompt, usually you will start with a context. Say, okay, you are a business analyst, you are a software developer, you are a party planner, or you are something like that. So with sentences or context, you already transfer ChatGPT from a generic reading comprehension one into the one in a particular context. So basically, within your chat, your prompt, like today, you have your context embedded in here, in plain text for that particular purpose. So we can say in your prompt, you have your knowledge, or you have your model embedded in there, and then you have your requirements. So for example, here is a requirement. I want you to write a code for me. So through ChatGPT, and then you generate your final result, which is a code. But what we can think, this is actually a more accurate for what actually happening there. So you have a requirement, you have your ChatGPT, and you have your model or your context embedded in there. So with those, you already transfer the ChatGPT from a generic reading comprehension AI into they understand your current requirement and this sort of thing, and to like generate this final code and this final result. That is actually give us a really unique position today, because traditionally transfer learning will take days, weeks, or even months. But today, with this type of thinking, you can actually tweak how you curate your knowledge and transfer your knowledge in seconds, minutes, or hours. That is as long as that takes. Because then you can change the way you describe your knowledge, and you can immediately get this feedback. Did I read it right or wrong? So that is the really unique thing about large language model, and that is the very first time we can have a really handy tool can do really fast, really cheap transfer learning. So that is we never had before. That is actually we never had before. So then here is one of this examples. So the team AI, like Rachel mentioned before, because this is I invented like this idea. So here you can see here is a business like description for what is the current problem, what is the current situation, what is the core concept like within here. So the business analyst or someone can actually in here to change the context. And here is a like user story. So the user story is basically here is the functionality we want to do. So we actually make the ChatGPT to ask a question to clarify this user story based on this context. So then you can change your user story, or you can change your like business context, and ChatGPT will based on the context to ask question about your like user story. So that is actually means someone can starting here to writing to writing all your knowledge down to talking about something, and then if ChatGPT is starting to ask really sense-making question, it actually means you have done a really good job to capture your knowledge. So if the question ChatGPT is asking is far from to close the deal, to have really detailed information to confirm, it's from the very beginning talking about, I don't understand this term in your context, can you like explain more? Which is actually means you actually missing some really important concept here within your context like description. So that is a way we're actually using to think about how ChatGPT can actually change our way to acquire knowledge. We can acquire knowledge in an AI understandable way. So once the AI can understand this knowledge, then they can perform task and action based on those actions now. Or in a more way, like we can say, large language model today, if you acquire this knowledge in an AI understandable way, so large language model can actually make it as a working knowledge. You don't need a working software. So large language model can be a generic architecture or interpreter for your knowledge. So we can give you guys a really simple example, really simple. Because just like consider you have an e-commerce website. And within this e-commerce website, you have the product with the price. And then you have your like discount rule like described in the human language. And then it's really easy today to write a prompt to calculate the price of the order. Say, okay, here if I purchase product 1, how many times? If I product 2, how many times? And what is the total value? So which means, like before today, we need a software to actually convert those into something runnable. But like today, with ChatGPT, we just put in the knowledge and the context like in there, and with a really simple prompt, you can actually execute some action based on the knowledge you have, based on the knowledge you have. So today, from there, we can actually see some really interesting new development for the technology like around large language model today. It's actually we're actually seeing those is a large language model powered autonomous agent. So please consider ChatGPT. So what is the difference like between a ChatGPT plugin and you're talking to like ChatGPT directly? Because when you're talking to ChatGPT directly, so as a chatbot, basically you as a human to control the overall interaction, how human is going to be interacted with this AI. But in the ChatGPT, like the plugin scenario, it's actually reverse. It's actually the AI to control how I want to interact with the human and other plugins. So when you ask a question, the ChatGPT well decided, oh, there's a piece of information is missing. I can actually Google that. So they definitely will ask your permission. Can I Google those information because I don't know that? Or you can give the answer. Because you're going to say, okay, you don't need to Google this information. I can tell you. So basically, this autonomous agent thing is a reverse for who control the overall procedure between the interaction with human and AI. So once the reverse is done, we can have the agent there, we can have the AI there to control the whole thing. That will become a generic architecture. Generic architecture from today to the AI era. Because starting from today, once you have this architecture figured out, it will be the next really big architecture pattern everyone will use. Because the basic idea will be, if you have a business procedure, the AI will run the procedure. At the very beginning, AI will say, here is a plan now run. So then they're going to ask a human, so whether that plan looks good for you. The human says, sure, give it a go. So then the AI going to execute each single action. The AI thought is going to be suitable in this condition. Some of the action may require the collaboration from human. So we actually make the joke. Today, people all talk about we should using AI to augment human, but actually tomorrow we're going to using human to augment AI. So it's actually AI to do the work, but human can provide the supervise, and the AI well decided when and where I need help or permission from a human. So that is actually when we're talking about this autonomous agent thing is going to happen. It's already happening. So if you're looking like today's open source framework, the new framework came into the community. It's primarily focused on how can we actually building the agent faster, better, and with lower cost. So then we'll say we can use large language model as a general knowledge runner. So with that, so it's going to fundamentally bring a paradigm shift for software development today. Because before, we need the whole procedure to curate the knowledge. Because just as like Ruja and the other one is talking about, because the whole design thinking thing, we do all this sort of thing, and then we need a software to prototype that. But now we don't, because once you have the knowledge ready, it's actually most of the work is actually done. We can actually put those into a large language model powered agent to run the experiment or to run the whole thing directly. So that is actually not a bad thing, because consider we mentioned before, because software itself is just a medium. Because we can always change a medium from a working software into a generic AI or generic AI architecture application. We can always do that. But something will never change. That is the real product embedded in every single software. Is actually the knowledge is actually really important. So it's actually, if we don't we may not need the working software today to close the loop, because we can have the large language model help us to do such a thing. Or even more, it's actually the time, for the first time in software delivery, we can, so if the large language model can help us to close the feedback loop, we can actually focus on the true product we've been working on for many years. It's actually the knowledge embedded in the software. So that is actually the thing. The very first time, as an agile believer and as an agile coach for many years, I will now tell people, working software may not be your top priority in the large language model or in the AI era. So we should thinking something more fundamental and to looking for something that will be more interesting. Thank you.